Hello, and welcome to day 3 of Calculus in a Year. Today we'll be going over trig functions. We have these 6 trig functions here. We have sine, cosine, tangent, cosecant, secant, and cotangent. And we use 3 letters for each of them as a shorthand. So cosine is just cos, tangent is just tan, and so on. Now, in the context of a right triangle, the sine of an angle theta is equal to the length of the opposite side divided by the length of the hypotenuse. And the cosine of angle theta is equal to the length of the adjacent side divided by the length of the hypotenuse. Now, how would we find the opposite, adjacent, and hypotenuse? Well, if we have an angle right here, theta, the opposite side is the opposite side. So, the opposite of this would be right here. So this is our opposite. And then the hypotenuse is the longest side, and it's the one that's right across from this 90-degree angle here. So this would be the hypotenuse. And so that means that this must be the adjacent side. So if I were to ask you to find the sine of angle theta, it would be the opposite divided by hypotenuse, so 4 over 5. That's equal to 0.8. If I were to ask you to find the cotangent of theta, that would be equal to the adjacent over the opposite, so that would be 3 over 4, 0.75. Now, here's a very helpful tool to remember your trig functions. Well, specifically these 3 over here. These 3 are the ones you're going to see very frequently, especially sine and cosine. So we have SOHCAHTOA, where S stands for sine, and then we have this O and the H. The O stands for opposite, and the H stands for hypotenuse. So sine is opposite over hypotenuse. Cosine, represented by the C, is equal to the adjacent over hypotenuse. So we have AH, and tangent is the opposite over adjacent, so that'd be OA for opposite and adjacent. So it's a very helpful tool for remembering these 3 trig functions here. Let's practice finding the values of these functions. So we have angle theta, and we want to find all the values of these trig functions. First things first, we need to find our opposite, adjacent, and hypotenuse. The opposite of angle theta would be over here. The hypotenuse is opposite of this right angle, so that would be over here. And then this must be our adjacent side. Okay, so sine of theta is equal to opposite over hypotenuse, so 5 over 13. Cosine, that would be equal to the adjacent over hypotenuse, so that would be 12 over 13. Tangent is opposite over adjacent, so that's 5 over 12. Cosecant, that's hypotenuse over opposite, so that's 13 over 5. Secant, hypotenuse over adjacent, that would be 13 over 12. Finally, cotangent, adjacent over opposite, that would be 12 over 5. Now, how can we use this for right triangles, these trig functions? They can help us to find the values of angle theta, and they can also just help us to find the length of a side. Let's start off with finding an angle. So say if I have angle theta here, and I wanted to find its value, we could use a trig function to help us find it. Let's say I would advise you to use either sine, cosine, or tangent. especially because those are available. Those three functions are easily found on a lot of calculators. But yeah, let's use cosine to help us find the value of angle theta. So the cosine of theta is equal to the adjacent length of the adjacent side over the length of the hypotenuse. So let's find the hypotenuse, the adjacent, and the opposite. The opposite is going to be opposite of this angle theta, so that would be here. Hypotenuse is the longest side. It's across from the 90-degree angle here. And then this would be our adjacent side. So that means cosine of theta equal to adjacent over hypotenuse. Alrighty, so we found the ratio. Now how do we find the angle of theta? You're going to need to use your calculator for this. You use the inverse function, inverse trig function. Cosine, inverse cosine of 12 over 13. Bring that up on the calculator. Inverse cosine 12 over 13 is, rounded to 2 decimal places, it would be approximately 22.62 degrees. Alright, and we could have also used a different angle that we wanted. We could have also used, for example, tangent. So tan theta is equal to opposite over adjacent. So that means tan theta is equal to, let's see, if the opposite is 5 and the adjacent is 12, which means tan inverse of 5 over 12 is equal to, our calculators once more, we get the same answer, approximately 22.62 degrees. So yeah, as you can see, we could have used any of these trig functions and used the inverse function to get the angle. And just a word of precaution, the inverse trig function, it's different from simply raising a trig function to the power of -1. So they're not the same thing. So don't confuse the inverse trig function with simply raising a function to the power of -1. Now, let's try to find the length of angle of side x. How do we do that? Well, let's see what we have. We have the value of theta. So theta is equal to 51 degrees. And let's see. This is the opposite side. We have opposite equals 17. Yeah, 17 feet. And then let's see, what are we trying to find? Let's see, if this must, x is the adjacent side. So adjacent equals x. And we don't actually need to write feet here. We can just leave that out for our purposes. And we can just add it in at the end. But yeah, let's see. We know theta, we know the opposite. We're trying to find the adjacent. Going back to our trig functions, tan of theta, we have the opposite, and we're just trying to find adjacent. So let's use tan of theta to help us find the answer. Tan theta, I'm just going to write it up somewhere else. tan theta equals opposite over adjacent. Let's see, we'll substitute for theta and opposite, and we get tan 51 equals 17 over x. We're substituting x for the adjacent. Now we'll multiply both sides by x. So then this will give us, multiply both sides by x. We get x times tan 51 equals 17 over, just 17. And finally, we divide both sides by tan 51. We get x equals 17 over tan 51, which means, if we use a calculator, x is equal to approximately 13.77 feet. We just add this feet part at the end. So yeah, that's how we can find the length of a side using these trig functions. Now, one thing to remember is that what we have learned so far can only help us to solve right triangle problems. In a future video, we will learn how to generalize what we've learned. We'll learn how to extend it to include any triangle. Alrighty, so I'll put some problems in the description and the solutions. Only check the solutions if you're thoroughly stumped or if you're done. But yeah, otherwise, thank you, and I hope to see you back.